Okay, and our next presenter is Dr. Jesper Chia Hui Hsu, who is a veterinarian, and currently he is almost done with his PhD. He has a final defense later this month. So we do appreciate him joining us today and his busy schedule today and this week. So thank you, Jesper. And he's going to talk about one of the projects for his PhD, and his presentation is called "From Outbreak to Ongoing Impact: 5 Years of African Swine Fever in the Philippines." We have a recording of his presentation, but Jesper is today with us, so he will be able to answer your questions after the presentation. I think we don't have sound.
Or I could just interrupt. Is it okay?
Of course, Jasper. I'm sorry. I don't know what's going on with it.
Time, so I will just quick and skip the background. Okay. So as Rachel has presented, the African swine fever is a double-strand DNA virus with a very complex structure, encoding over 150 proteins. And the clinical sign would be pretty similar to other common infectious disease like uh, classical swine fever or some common infectious disease. It has shown the high fever, decreased appetite, diarrhea, or vomiting. But one of the symptoms which not need to be noticed is abortion or sudden death. And the mortality could be very high, up to 100%. So I think most of people has already know with the disease, but I will just go quick about the scenario in the Philippines. Philippines is located in the center of Asia Pacific countries, and the left figure and the right table showing the first year and their transboundary animal disease outbreak status in East and Southeast Asia. And Philippines is an archipelagic country with more than 7,600 of islands in Southeast Asia. The weather and the temperature is pretty maritime and tropical. Currently, Philippines has no foot and mouth disease outbreak, and the first ASF cases is in July 2019. And here is an overview of animal health impact as shown in Rachel's presentation. At the beginning of the first year, 2019, there's only 3 cumulative affected regions in the Philippines. But by the end of 2023, 100% of the regions and 89% of province has shown positive detection. And the Department of Agriculture in the Philippines have a bi-weekly report of African swine fever endemic cases. This map is just updated 1 week ago, showing some endemic in many regions. And the left figure is a typical swine farming system in the Philippines called a backyard or smallholder farm. It's holding more or less 1 to 20 heads of pigs in the Philippines. It constitutes 70% of the farmers in the Philippines. And as for statistics, in the right chart, the backyard is slightly decreasing and the commercial farm is slightly increasing over the past 30 years. But the ratio is still maintained like 70 to 30% comparing these two kinds of farm types. In our research question, we have main 3 research questions. First is we want to descriptive spatial and temporal analysis means identify where or when is the disease happening more frequently. Secondly, is we want to identify specific pattern in the transmission of the disease in the Philippines. The third is if there's a pattern, what are the risk factors in the context of the Philippines? So we use the data from the government with over 19,000 of front outbreak at the beginning of the disease outbreak to its 36 months of the data. So here is the general data set look like. We have date, months, year, and different region and administration level and the positive case at the fund level. We use the centroid of the smallest administration level to mapping the data. We have a bunch of geostatistics methods and going in our programming. But basically, we are going all three. First is spatial epidemiology. Second is disease dynamic and the risk factor analysis. So for identify a space-time dynamic, we identify the central region as showing the higher case sum and the higher density of disease. And for the epidemic curve, here is at the beginning of the disease, August 2019 to the June 2022, we have showing different epidemic curve, and there's mainly 4 peaks. 3 of the peaks lies in the second half of year, showing the darker orange. So we separate the first half of year from January to June, and the second half of year, July to December, in these figures. That's showing an epidemic curve of pattern of ASF recurrence over years. And we also using statistic tools showing a seasonal pattern with the high season in August to October and the lowest between April to May. Therefore, we also do a space-time permutation test. This is showing where and when is the disease happen in the similar time frame. We identify 5 clusters, and the cluster 1, cluster 3, and cluster 5 all happen in Luzon Island. And it's specifically showing outbreak is clustered in second half of year between September to December. And importantly, we can see the radius of the map. The radius from the cluster 1 is 55, but at the end of cluster 5, it becomes 107. So that means the impact region is become broader than the previous year after 3 years of infection. And then we use the data to modeling the disease dynamic. We use a method called a basic reproductive number. It is meaning to measure how contagious an infectious disease is. If we are evaluate other infectious disease like COVID, it is typically in an individual level. But given our data availability, we only have fund data. So the reference of this meaning in our data set is how many secondary farms one infected farm will cause on average. And if the number is above 1, means the disease is spreading fast, leading to a potential outbreak. If a number is below than 1, means the disease will die out or being eradicated. If R equals 1, means the disease is becoming endemic and become stable. So here is our result over 36 months of data. At the beginning, the 95% confidence interval is between 1.1 to 6.5. But at the end of the data set, it becomes 1.01, showing an endemic phase trend. We also use different kind of disease dynamic tools to show if we can get similar pattern. At the national level, we have showing the similar trend of endemic. So the third question is, what is the risk factors for in the Philippines context of ASF? We use a method called a conjoint analysis. It is basically a questionnaire forms to ask the expert in the field to prioritizing the risk factor in the Philippines. So we use different kind of simulated forms, and it is a questionnaire for the experts to fill the form, to ranking different kind of farms and showing if this kind of farm will have outbreak or not. There's a 13 simulated farm in this questionnaire. So here is just one of the hypothetical farm example. We have identified 9 risk factors, and we binary choose each of the factor is yes or no. Like this one is yes, they use a swale feed, but not use a double fencing, no ticks or flies in this simulated farm. And the participant will need to answer if you believe this farm will have an AS outbreak or yes or no, and rank different hypothetical farms like the previous questionnaire. So using this kind of questionnaire and our expert selection, we can using the statistic model to modeling the risk factors. So we want to compare the impact of human behavior and other environmental risk factors in the Philippines. And our running this kind of statistic models, we are showing that the top 3 risk factor is all in human behavior. The top 1 is the use of swale feeding. The top 2 is personnel movement without trusted biosecurity. And the third one is lack of disinfection protocol as the key risk factor for ASF introduction in the field. And we also using the workshop to discussing the actions of human behaviors to understand the compliance and non-reporting cases. The government mandate total depopulation, but the compliance rate between backyard and commercial farm is between 50% to 80%. And we all notice that animal will be sold as soon as the disease is noticed in the field. So that will cause a continuous problem in the logistics and the supply chain. And we have identified that there is more than animal disease in the field. As Rachel has presented, there is also social economy, public health, and environmental issues in the Philippines. The price of pork has risen significantly year on year, and there's a lot of stress, veterinarian, and also a financial hardship for the farmers, the producers that experience mental health issues. And also, there is an environmental impact, especially in the dumping carcass in water sources. It will potentially pollute the air, water, or soil in the environment. It will change the ecology. So all the research summaries, first, we are showing the recurrence pattern of ASF in Rizon Island, with a seasonal index is highest between August to October. And second, human behavior is a main driver of ASF spreading, highlight the need for intervention on biosecurity and movement control. The third is evidence of ASF transition toward an endemic stage in the Philippines. So prepare for endemic state for long-term prevention and control will be very important. And further, public-private partnership will be important for future research. So here is a same conclusion as Rachel's presentation. We need not only thinking ASF as an animal health issue, but also public health and environmental health to mitigate different kind of negative impact in both of the One Health scope. And if you have questions, here is my email, and I'm happy to respond to the email if you have questions. Thank you.
So much, Jesper. And I apologize for our technical difficulties at the beginning, but you did a great job, very resistant. Thank you so much again. Dear colleagues, do we have any questions? Okay, Jesper, I have a lot of questions, but I know that we don't have much time for that. So basically, we will do our debrief later today. But I am actually very interested in vaccination. We know that the Philippines just roll out their vaccination campaign, and I want to know your perspective on the vaccination campaign in the regard with endemicity of the disease. Is there um, any aspects you would like to highlight in this regard?
Okay. So first, because okay, I will go back. So because there's 24 genotypes overall, and the mainly genotype in Asia Pacific is the genotype 2. So the vaccine, ASF vaccine, is mainly made by the genotype 2. But however, uh, currently there is a genotype 1 and genotype 2 combination of ASF happen in Vietnam, China, and Russia, according to literature review. And Vietnamese government, or no, Vietnamese lab has also showing a literature that genotype 2 vaccination doesn't help the recombination strength in Asia Pacific. They're showing the evidence. Fortunately, in the Philippines, there is currently only genotype 2, and they are rolling out the genotype 2 vaccination. But there is some like pros and cons of the vaccine. But generally, for future preparedness, even if the genotype 2 vaccine can protect the genotype 2, but once there is a new introduction of a recombination, there's no way to prevent the recombinant of the both genotype 2. So it will raise a significant concern. Should we use this kind of vaccine? It's not only the academia things, it's also related to government or the political issues. So I have no good answers, but I need to remind for a scientific point of view, this kind of immunology need to be think about. And if you give the vaccine, you can provide the immunity to the swine industry, or it will introduce more issues. So yeah, thinking about that, it will be very important. Thank you.
Thank you so much, Jesper. It was great presentation, and thank you for your insights.